Let me now run through an example to illustrate how you would use these conditions to find either a maximum or a minimum. Yes, Ben?
Is that third condition not met, then it's a saddle point?
Exactly right. If this condition right here is not met, if it's violated, then you have a saddle point.
Which kind of looks like a...
Yeah, it kind of looks like a saddle. Actually, if you have your book, the book has some nice diagrams of surfaces in 3 dimensions. Let's see, it's in chapter 11. Let's see if I can find the page number. Yes, if you look on page 295, they've got an example of a saddle point. And a saddle point occurs where your first order conditions are satisfied, but it's neither a minimum or a maximum. As opposed to a maximum and minimum, which are illustrated on page 294. Okay, all right. And that's the reason, Ben, for these conditions. Okay. Consider this function right here. Z is a function of x and y, and this function f is this: 100x minus x squared plus xy plus 100y minus y squared. For this function, we want to find its maximum or minimum. Okay. So how would we proceed? We want to find if this function has a maximum or a minimum. How would you begin? Diana, I can tell you what to answer. Right. Right. And what do we do with those partial derivatives? Yeah, we set them equal to 0. That is just our first order condition. It's the same first order condition for either a maximum or a minimum. Right now, we don't know whether we're going to find a maximum or a minimum or neither. Okay, but let's see. F sub x, just a partial derivative of that function with respect to x. And obviously, if you differentiate, you get 100 minus 2x plus y. These last two terms, of course, don't involve any x, so their derivatives are just 0, so they drop out. So you set this equal to 0. And then we look at the partial derivative of this function with respect to y. And doing this, we get x plus 100 minus 2y equals 0. Okay, so those are our first order conditions. Are we all good so far? Is this clear? Okay. Let me just rewrite these equations. Let me rewrite this equation as minus 2x plus y equals minus 100. And let me rewrite this equation as x minus 2y equals a minus 100. I don't like that minus sign over on the right-hand side. So let's multiply through both of these equations by minus 1. Doing that, we get Oh, if we multiply that first one by -1, we get 2x minus y equals 100. Multiplying this one through by -1, we get -x plus 2y equals 100. Two linear equations, two unknowns. We go all the way back now to chapter 4. Now, we've discovered the critical values of x and y. The critical values of x and y are the values that satisfy the first order conditions. Now we need to make sure that we have either a maximum or a minimum. So what do we check now? To figure out whether we have a max or a min, what do we check now? Ryan? Yeah, take the second derivative, because here's our second order conditions for a maximum. Our second order conditions are right here. So we need to find f sub xx. We need to find f sub yy. We need to find f sub xy. Okay. So we got f sub x right here. What is f sub xx, Ryan? Yep, it's just a -2. What about f sub yy? Yeah, f sub yy, it's partial derivative of this with respect to y, so it'd be -2. So far, it's looking like what? A max, because both of these are negative. But to be sure, it's a maximum and not a saddle point, which would be neither a minimum or maximum. We need to check this second part. Now, f sub xx times f sub yy is what? 4. -2 times -2 is 4. F sub xy, which is by definition the partial derivative of f sub y with respect to x. At least it's by definition in this book. Okay, that's what f sub xy is. And what is this equal to? We want to take the derivative of f sub y with respect to x, and it is equal to, what did you say? 1. Coefficient on x is just 1 here. So that means f sub xy squared is just 1 squared, which is also 1. So in this case, f sub xx times f sub yy is 4. That is greater than f sub xy squared. So this is greater than f sub xy squared, which equals 1. So we know that we have a maximum at x equals y equals 100. At these critical values of x and y, we have a maximum. And that means that the maximum value of z is found by just substituting back into this function, x equals 100, y equals 100. So let's call this value z star. Z star is just f evaluated at 100 and 100. And just plugging into this, you get 100 squared, 100 times 100, minus 100 squared, plus 100 times 100, another 100 squared, plus 100 squared, minus 100 squared. So these cancel, these two cancel, you just get 100 squared, which is 10,000. So z star, the maximum value of this function is 100,000. Oh, 100, wait a second. Oh, 10,000. I meant to say 10,000, not 100,000. Yeah, because if you take 100, you add on 2 more zeros, you get 10,000.